Before we go over the method, I need to explain a quick concept that is crucial to understanding why the method works. And plus, it also helps you understand how and what exactly MSO is actually doing. I'm sure you guys have seen this tab before, All SPL. That shows you the frequency response of the subwoofer. But a much more important tab that everybody seems to forget about is this one, SPL and phase. Here, we not only see our frequency response, but also our phase, which is probably the most important measurement that you should be looking at. On the top, we have 180 degrees, and it goes down all the way to negative 180 degrees. Let's call this one cycle. And if we keep looking to the right, you see that the phase repeats itself across the frequency. Some are longer than others, while some are very short. In a perfect world, the phase response would have equal separation from one another across the whole frequency. But we don't live in a perfect world, so some are short and some are longer than others. Now you might be asking why this matters. Well, that's because each subwoofer that you measure will look a little bit different. This is due to the fact that subwoofers are placed in different spots, thus they create different room modes, and thus we get different phase responses for each sub that we measure. That's going to be a problem because when we're going to phase align the subwoofers using MSO, we're going to have problems aligning the phase to the subwoofer at some frequencies. Let's go back to All SPL and click on Controls icon. Then let's click on Alignment tool and then click on Show Phase Traces. On the top, let's select one of our subwoofers at the main listening position, and let's do that with another sub on the bottom. Now we see both our subwoofers each in different colors, and we also see the phase of both subwoofers in black if we were to align them, or in a more simpler way, if we play them together at the same time. Now notice that when we add delay to one of the subwoofers, that subwoofer phase moves to the left, and if I add a negative delay, the subwoofer moves to the right. Now, another thing that I want you to notice is not only is the phase moving, but it's also decreasing or increasing with phase cycles, depending on if I give it positive or negative delay. So, how do we know if our subwoofers are aligned? Well, it's pretty simple actually. Anywhere where both our subwoofer phase is in parallel to each other to about 30 degrees will produce positive summation, or in a more simpler way, if they play at the same time, it will be louder. Because as you can see, while our subwoofer does indeed have positive summation at 20 to 40 Hz, we do not see the same for the rest of the frequency. Let's go ahead and slowly move the delay of our subwoofer and see what happens. So as you can see, delaying the subwoofers helps align some of our phases. You can see that 60 to 80, 80 to 100, and 100 to 130 is mostly aligned and has positive summation on the frequency chart. Now notice this null right around 52 Hz. If we look at the phase chart, we can see our behind subwoofer is adding a phase cycle right around 47 to 60 Hz, causing a null because we do not have that same cycle for our right subwoofer. And if you look at our frequency chart, we don't see any indication that neither subs has a null there. That's why phase is so much more important to look at. It helps you better understand what the problem you're dealing with is and how you might be able to fix it. Okay, now that we know the basics of phase, I'll go ahead and explain the method. When we're optimizing using MSO, MSO will often never give you the result for max output. That's really because of one simple thing. MSO is only looking for the target curve, i.e., the closer it gets to the curve with all seating positions, the better. That's what MSO thinks. Now the problem with that is what we talked about earlier. Phase can affect different frequencies depending on the delay. That means that at 15 milliseconds of delay, we have very great phase alignment over in the higher frequencies, but a bad phase alignment at around 30 to 40 Hz. Now let's look at 23 milliseconds of delay. We still have great phase alignment in the higher frequencies, but now our 30 to 40 range no longer has that null. This would mean that 15 milliseconds would cause you to have less max output compared to 23 milliseconds, around 7 dBs of range. And there lies the problem. MSO picks random delays and compares them to see which one looks flat. Not to find which one has better output, but to find the one that has a better delta for the target curve. So, what do? It's quite simple actually. We just need to find the delays ourselves. Instead of letting MSO decide the delays, we'll give MSO the best numbers that will result in the best output, and then force MSO to optimize using those numbers. I'll first find the phase that aligns best with right and behind. And it looks like 23 milliseconds with inverted polarity gives us the best result. Let's click on Align Sums and select it for our top measurement. Now let's go to the next sub. And it looks like we get good alignment at 70 milliseconds with inverted polarity. And for our last sub, we're getting negative 7 milliseconds with inverted polarity. Now let's head to MSO. Under Configurations, click on your config, and you'll see delay blocks for your subwoofers. You might notice that one sub will be missing a delay block. Don't worry about that, as adding negative delay will be the same as adding delay to the other subs. For example, adding negative 2 milliseconds delay to the left will give 2 delay to all the other subs, making left the 0 delay reference. Okay, let's go ahead and input our delays that we got from REW. There will be a min and max value, so let's just limit to 22.99 and 23. Now let's also add a polarity inversion. We'll do the same with the others. Notice that MSO shows the new response with the updated delay. Now let's go to our optimization tab and change a few settings. Our reference level doesn't really matter, but let's set it somewhere in the middle of our response. It's important that we optimize as high as possible. I won't have time to explain in this video, but for most of you out there, you should at least try to hit 200 Hz, and if you can, go up to 240 Hz. In a later video, we'll go over why. We won't be using sub input PEQ, so disable it. For max cut and boost, cut as much as you can and boost no more than around 10 dBs. Click OK. Now we're almost ready to start optimizing. Let's open a new graph and select our measurement groups. Click on Properties, your new graph, All Traces, and click Show Phase Only. On this graph, we're looking for any weird phase issues that might have popped up from our delays. If your phase are all parallel with each other for the most part in the lower ranges of frequencies, then you're ready to optimize. And that's it. Once you're done, just input your delay into your MSO and enjoy. There's still a few things I would still like to cover, but for now, this is enough for most MSO users to understand the method. I know I can be pretty bad at explaining things, so please go ahead and ask any questions that you guys might have. I'll be using any criticism to make a better video in the future. That's it.